So you guys might already be aware of the many different leaderboards that Arena produces, and today we're introducing a new one, which is a little bit different. It's a causal effect leaderboard. We call it causal tracing, and here it is. We have a leaderboard based off of a causal methodology. So we randomize the components in a given AI system, deliver that to users, and measure the outcomes. And that's what we're seeing here. The overall net improvement is the overall causal effect of choosing, for example, GPT 5.5 high over a random baseline. That also means that baseline will change. This leaderboard is more living than our previous ones because it looks at recent data and accounts for the fact that these component systems can and will change over time. We can add tools at any time. We could change the system prompt. We can add more models to the pool, and so on and so forth. We need to be able to evolve as the capability evolves. And that's what we're measuring here. Given a world of capabilities, tools, system prompts, harnesses, so forth, what does choosing this specific configuration give you over choosing randomly? We measure this in a couple different ways. That's these signals to the side, which power this main net improvement score. Let's take a second on these signals. So we have 5 here that we're choosing to release today. It's confirmed success, praise and complaint, steerability, batch recovery, and tool hallucination. These are observations from interactions themselves. And of course, because our interactions are randomized, these have a causal interpretation. Confirmed success is the simplest. When you use agent mode, there is a pop-up upon each turn that asks if the task was successful or not. And confirmed success looks at the end of task boundaries, if the user said, yes, this is good, or no, I don't like this. And the models, and I'll sort it by that. Some models have much higher task success than others. We can look at the implicit version of this, which is praise versus complaint. Here, we see the models that receive explicit praise from the user. So that's a user saying, absolutely, I love what you just did. Or, hey, this is slop. It doesn't work. I hate it. Please fix it. That would be a negative reaction, of course. We also look at some other signals. We look at steerability. Steerability is about whether fixes land. It's inevitable that as we work with agents, there will be things that don't look right to us or mistakes that are made, and it's important that these models are able to correct them. And so we measure that when these mistakes happen, how quickly and how effectively can the agents correct those mistakes. We also look at batch recovery. Since we have a sandbox, we can watch when models use the bash tool, and we can watch when they potentially error on the bash tool. And we can look how long it takes to recover from that error. Now, we're not punishing the error itself. It's okay. Errors are natural. What we want to see is how long does it take to go from an error state to a clean state. Finally, we have tool hallucination. Tool hallucination looks at when model simply makes up tools that don't exist. And this is something that is reasonably rare, but it shows the model is, well, frankly, it's making stuff up that doesn't work. And so that breaks the session. And that's something we don't want to see in our models. And a lot of models have no hallucinations. For example, the top few models here all had 0 hallucinations throughout all their agent arena conversations. We show some more natural language tidbits here on what models are doing. For example, GPT 5.5 earns lots of praise. People seem to love this model when they talk to it, and they will say, hey, what you've done is really great. I should also add, I think Claude Opus seems to get tasks done. People like to indicate physically that Opus has been successful. We have per signal cards here that show in a bit more detail. We can cover these. For example, we can look through the full leaderboard for confirmed success specifically. Again, this one is telling the explicit pop-up of when users hit yes this task was successful. Same with praise complaint. We can see the full leaderboard. And of course, we could look at just the labs. Some leaderboards might look a little funny on the front, like tool hallucination. It looks like everybody's the same. And that's because most models don't make a lot of hallucinations. It's a rare event. But if you scroll down, you'll see some models are particularly large offenders who produce a lot of hallucinations with respect to others. Of course, all these leaderboards are relative. So it says, hey, if I pick this model instead of randomly, I'll get many more tool hallucinations than if I didn't. So what are the types of things people do on agent mode? It's really, really quite broad. We have, I think, on the order of hundreds of thousands of conversations per week. And those conversations vary in depth. Some of them even use hundreds of tool calls. Many of them are also very long context. Many individual sessions can be resolved within under 100,000 tokens, but there's a select few that go beyond that, on the order of 500,000 or a million context. We have lots of different tools. Mainly the most widely used is Bash. I think in the past week, we've evoked Bash nearly 1 million times. And that's a versatile tool for all sorts of things. It could be from workflow automation. That's like, I'll pull this YouTube video, get me the transcript, upload that to a Word document, and then convert that to a PDF, and then, get me timestamps or something like this. It could also be coding. It could be build me a personal website. From that personal website, turn it into a resume, and so on and so forth. All of these are enabled through Bash and Writefile and our sandbox workspace. And we've seen that people are heavily using this. There's roughly 30% or so of the tasks we see on agent mode are coding tasks. A large percentage is also research. So that's like people looking things up, checking for news. That's web search dominated. I couldn't begin to explain all of the different things people do. And so when we get to observe the things that people do, we produce these leaderboards, and that's exactly what these are powered by. So this is not necessarily just a coding leaderboard or just a research leaderboard or web search leaderboard. This is a real usage leaderboard. And yes, a lot of it is coding, roughly 30%, but a lot of it is other things, other very creative things people have figured out what they can do with agents. And of course, some of it is normal day-to-day things like help on understanding concepts and so on and so forth. Not everything is a tool call heavy. Looking at the labs screen here, we can see that the gap is quite large between OpenAI and Anthropic and the rest of the pack. It's clear that those two providers are way ahead when it comes to agentic capabilities, and everyone else is still in a game of catch up. OpenAI and Anthropic are neck and neck. They're within confidence, so technically it may be hard to say one is exactly better than the other, although it seems that GPT 5.5 High is a very, very strong model. So Agent Arena is a fundamentally different way to measure these models compared to what we've done in the past. For Agent Arena, we're looking at randomized single-wise traces, and we're analyzing those traces to produce outcomes and deliver this causal effect leaderboard. That also means we are able to measure much more than what we did previously. For example, here we have bash errors and tool hallucinations, and I expect that we'll add more interesting metrics over time. So we may look at file download rates, or we could look at different types of model behaviors. And those are things that we're going to add very quickly as we keep going here in order to deliver deeper insights into what exactly agentic AI is doing in the real world and what people are doing with it.